Hello everybody, and welcome to our video on absolute value and inequalities. So here we're going to be talking about this because we really need a strong foundation in understanding what absolute value means and how to work with the algebraic inequalities that are going to arise later in calculus. So yeah, let's go ahead and just jump right in. What does the absolute value of x mean? Well, in general, the absolute value of x represents the magnitude, size, or length of x, depending on the specific context. So if we take a look here, our definition, if x is a real number, then the absolute value of x means the distance from x to 0. So we see here's 0. If we've got the number x or the number negative x, in both cases, the distance away from 0 is the same thing, right? So the absolute value of x and the absolute value of negative x are both equal here. So this does lead us to another equivalent definition for the absolute value function, the piecewise definition. So let's just take a look at this here. So the absolute value of x is x if x is greater than or equal to 0, or negative x if x is less than 0. And this is equivalent because if we take something, let's just look at an example, like the absolute value of 3. The absolute value of 3 is, of course, 3. And if we look at the absolute value of negative 3, we get also 3. Okay, so how do we compute this? Well, if we take a look at this definition, the absolute value of x is negative x if x is less than 0. So let's write that out explicitly. If I have negative 3 as my x, then the absolute value of negative 3 is negative 3, which of course makes this positive. So pretty straightforward. Now, really right now what we want to focus on isn't the piecewise definition, though. We want to focus on the thinking about the absolute value as distance. That's going to be what's most useful to us right now. So now we're going to expand this definition. If x and a are real numbers, then the absolute value of x minus a means the distance from x to a. Okay, so when we look at this on the number line, what do we see here? We see if we look at x minus a, the absolute value of x minus a is the distance from 0 to that number x minus a. But we can also look at the distance between x and a, and we see that this is going to be the same exact distance as the distance from x minus a to 0, right? So we can expand our definition of the absolute value to say that if we look at the absolute value of x minus a, we're talking about the distance between x and a. All right. Now let's go ahead and move on, and we're going to just briefly touch on this idea in multiple dimensions, right? So we can often denote distance in 2 or 3 dimensions with the absolute value as well. So if P1 and P2, which are points x1, y1, and x2, y2 respectively, then the distance between P1 and 2, that's the distance between the points, we're also going to denote this as P1, P2 bar. Now, how do we read this? We read it as the length of the line from P1 to P2. Right? That's another way to read this. We can think of it as the distance between P1 and P2, or the length of the line from P1 to P2. And that distance is given by the formula here. The absolute value of P1, P2 is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, where does this formula come from? Well, it's pretty simple. We just take a look here at 2 points plotted on our Cartesian plane here. Got x1, y1, and x2, y2. And if we draw the line between these 2 points, what we notice is we can also draw, in red here, the legs of a right triangle. And so the distance on this bottom leg is the distance between x2 and x1, right? It's the same length here. So this leg of the triangle is x2 minus x1, and this leg of the triangle is y2 minus y1, right? The distance between y2 and y1. And so, of course, we could think of this as our A, our B, and our C. And the Pythagorean theorem gives us a squared plus b squared is equal to, not plus, is equal to c squared. And then when you take the square root, you get c is the square root of a squared plus b squared. But of course, a and b are right here, x2 minus x1 and y2 minus y1. Okay, so that's our distance formula in 2 dimensions. And we can pretty easily extend the distance formula in 3 dimensions. So if we have 2 points, P1, that's x1, y1, z1, and P2, which is x2, y2, z2. If these 2 points are in 3D space, then the distance from P1 to P2, then this magnitude of P1, P2 is the distance between the points, and that distance is given by the formula below. The absolute value of P1, B2 equals the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Now, I've got an image here that we're going to take a look at just to understand where this formula comes from. But for ease, I've centered my second point on this at 0, 0, 0. Right, so in this case, or we could say that's the first point. In this case, x1, y1, and z1 are 0, 0, 0, just to make it a little bit easier to see this picture on the graph. So when we look at this point up here is our x2, y2, z2, right, which I've just labeled x, y, and z on the graph here. It's easy to see that this red line here that stays on the plane where z is 0, it's easy to see that that red line has length square root of x squared plus y squared, because when you draw out your distance on the x-axis and your distance on the y-axis, you get x and y. X squared plus y squared is that distance squared. So pretty straightforward. Now, when we look at this triangle here, what we see is, okay, the square root of x squared plus y squared plus z squared is d squared. So of course that gives me x squared plus y squared plus z squared is d squared. And so d is the square root of that. And again, in this case for ease on the diagram, I made the second point 0, 0, 0. But we can easily see if this second point was somewhere else, all the same logic would apply, and we would get our more general formula up here. Okay, so let's go ahead and work through some problems. We've got the absolute value of -4. Well, our piecewise definition says this is -4. That's 4. The absolute value of 6 is just 6. The absolute value of 9 minus 15 is the absolute value of -6, which is -6, which is +6. Okay, now we've got a distance between 2 points in 2 dimensions, P and Q. So this is going to be square root of, all right, we'll take Q, that's x2 is 7 minus x1, so 7 minus 3 squared plus 2 minus 2 squared. That gives me the square root of 4 squared plus 0 squared, which is the square root of 4 squared, which is just 4. Okay. And now we've got another example where we're looking at 2 points that are in 3-dimensional space, and it's basically the same thing. But now when we apply our formula, we've got to deal with x, y, and z. So x2 is 3 minus x1 is negative 1. y2 is 3 minus y1 is 2. And z2 is 6 minus z1 is 5. This becomes the square root of 4 squared plus 1 squared plus 1 squared. That's 16 plus 1 plus 1. That's 18. So that's square root of 18. And I can simplify this a little bit to 9 times 2 inside the square root, and the square root of 9 is 3. So this is 3 root 2. Okay, let's continue. Now, back onto our focus on the number line and thinking about the absolute value of a single number and its distance from the origin. So, when we look at the inequality expression, the absolute value of x minus k, that means the set of all x values that are a distance of less than k from 0. So this is given by the interval from negative k to k, right? So when x is greater than negative k and less than k. So if we look at that graphically, here we've got 0. What I'm looking at here when I look at the absolute value of x is less than k is all of the x values on the number line that are between negative k and k, such that I'm only going a maximum distance, or I'm going no more than k away. Now, if I change that expression slightly, and we look at the inequality expression, the absolute value of x minus a is less than k, now that means the set of all x values that are a distance of less than k from a instead of from 0. So this is given by the interval from a minus k to a plus k. So if we take a look here, here's a. I'm allowed to go an absolute value of k towards the right or towards the left. So that'd be like adding k or subtracting k. So that puts us on the interval from a minus k to a plus k. Okay, so draw a number line and shade it to represent each of the following expressions. Here we're looking at the absolute value of x is less than 5. That means I am allowing it to go out a distance of 5 in each direction. And there's my number line. Now we've got the absolute value of x minus 2 is less than 3. So here, we're looking at the distance from x to 2. And if I go 3 towards the right, that puts me at 5. And 3 towards the left puts me at negative 1. And so this interval should look like this. Now for C here, this one's a little tricky because we've got the absolute value of x plus 4. But remember, our distance notation here is the absolute value of x minus a. So we actually have to change this a little bit and write the absolute value of x minus negative 4 is less than 2. And then we see that the distance we're measuring from is from the number negative 4. Now we're looking at negative 4. And we're going a maximum distance of 2 away. So 2 to the right and 2 to the left. So that puts this at negative 2 and this at negative 6. And here's my number line. Okay, now let's look at this next one. Got the absolute value of 2x minus 6 is less than 4. So again, a little bit tricky here. But we can use some algebra, and we can factor out the 2 from this expression, make it 2 times the absolute value of x minus 3. And then you may recall from algebra that you can split up absolute values on products. So we can make this the absolute value of 2 times the absolute value of x minus 3 is less than 4. And the absolute value of 2 is just 2, so this is 2 times the absolute value of x minus 3 less than 4. Divide the 2 across, and we get the absolute value of x minus 3 is less than 2. So that means the distance from 3 is less than 2, so I'm going out 2 in each direction. That puts us on the interval from 1 to 5. All right, let's continue. Now we're going to solve some inequalities here. We've got the absolute value of x is less than 5. So whenever we're solving an inequality expression, what we've seen from earlier is that whatever I have inside the absolute value turns into this general expression. The absolute value of x is between a minus k and a plus k. Let's actually go back a step and make it simpler. The absolute value of x is less than k means that x is between negative k and k, right? We saw that that connection between the distance being bounded by k and the interval being given by x is between negative k and k, we can see that right in this picture. So anytime we try to solve an inequality of this form, we're always going to start by taking whatever is inside the absolute value and setting it between the positive and negative bounds of this number. So when I have the absolute value of x is less than 5, that immediately implies that x is between negative 5 and 5. And I'm done. That one's completely finished. Now for b here, the absolute value of x minus 2 is less than 3. That's going to imply that x minus 2 is between negative 3 and 3. Now I just add 2 to every side, and that gives me x is between 5 and negative 1. All right, let's look at c here. We've got the absolute value of x plus 4 is less than 2. So x plus 4 is between 2 and negative 2. I'm going to subtract 4 from each side, and we get x is between negative 2 and negative 6. Okay, and again, we've got the absolute value of 2x minus 6 is less than 4. So 2x minus 6 is between 4 and negative 4. I'm going to add 6 to both sides. That gives me 2x is between 10 and 2. And now I'm going to divide by 2, and I get x is between 5 and 1. Okay. Next, we're going to take a look at how we can rewrite certain inequality expressions. And this is really useful when we're trying to analyze the relationship of distances between a function's output and its input. This is something we're going to talk more about when we look at the formal definition of the limit, but we do want to practice the algebraic skills necessary to get to that point. So, rewrite the inequality in the form the absolute value of x minus a is less than k. So right now, we've got the absolute value of negative 3x plus 9, but I just want this to be an x without a multiple of negative 3. So I'm going to factor that negative 3 out, which leaves me with x minus 3 here. And by the way, I'm sure you'll hear me say this in plenty of videos. If you're ever unsure if you've factored correctly, just multiply it back. You should get exactly what you started with. If you did, then you're good. Now, as we said before, when we have an absolute value of a product, we can split up that product and make this the absolute value of negative 3 times the absolute value of x minus 3. So this whole thing is less than 2. The absolute value of -3 is, of course, just 3. And now I'll divide that 3 across, and I get the absolute value of x minus 3 is less than 2/3, which is exactly the form that was asked for. Okay, now let's take a look here at B. So we've got the absolute value of 4x plus 3. I'm going to start the same way by factoring out that constant 4 times x plus 3/4. Now I'm going to split up my product on the absolute value. That's for the absolute value of 4 times the absolute value of x plus 3/4 less than 5. The absolute value of 4 is 4, and I'm going to divide it. So I'm going to combine those two steps together this time. This is less than 5/4. And the only thing I've got left to do is I want to make sure that this middle expression is a minus here. So we're going to rewrite this as the absolute value of x minus -3/4 less than 5/4. Okay, moving on. Now we're just going to take a look at these two examples here. Write the following sentences using mathematical notation. The distance between runners A and B is 50 feet. So we're going to use A and B to represent the position of those runners. And we're also going to think of that position as just how far they've ran so far. And so we can just write the absolute value of A minus B is 50. All right, that's it for that one. And now, if a certain faucet is turned off at time t within 1 second of running for 30 seconds, then the volume of water in the sink will be no more than 2 liters off from a total of 15 liters. So how do we translate this into mathematical sentences? So a certain faucet is turned off at time t within 1 second of running for 30 seconds. So this is like the time that we're measuring at. And we're saying the distance, the length of time between t and 30 seconds is less than 1. All right, that's what this says. The faucet is turned off within 1 second of having ran for 30 seconds. So the distance away from the actual time to 30 is less than 1. Then the volume of water, so in other words, it implies that the volume of water in the sink will be no more than 2 liters off from a total of 15. So the volume, its distance away from 15 liters will be less than 2. Okay. Well, folks, that's it for this one. Thank you for watching.